Hello everyone. In this video, I am going to explain about computer vision. Computer vision is the field of AI, artificial intelligence, that enables computers to interpret and understand visual data. It mimics human vision, that is analyzing images, videos, and real-world scenes. And right now we are seeing the use of computer vision in various fields, especially all we know about self-driving cars, right? Driverless cars. That self-driving cars are getting operated all because of the developments happening with computer vision. Okay, it's a very important thing. Let us see about computer vision in this video. Okay, so let us see some real-world applications of computer vision. Obvious one is facial recognition. So for unlocking our phone, we are using facial recognition, right? So that feature is powered by computer vision. And self-driving cars, that is a very obvious application of computer vision. That self-driving cars are using computer vision techniques to identify the objects in the road and understanding traffic signals. For all these things, they are using computer vision. And obviously it is in real time, right? So that is the unique feature of computer vision that is now enabling a lot of new applications. The new developments happening with the computer vision are enabling us to do the object detection or any kind of computer vision things in real time. That is the key thing. And medical imaging. So we heard about various news saying that now AI is more powerful than doctors or radiologists in identifying the diseases by going through the scan images, right? So obviously computer vision is getting used in medical imaging, and it is in retail and inventory tracking and augmented reality, virtual reality, that kind of stuff. And another important thing is OCR, optical character recognition, for digitizing books and especially for reading text in the number plates of a car. So it's reading the characters in the image. Okay, so that accuracy and precision are getting improved with the help of computer vision powered by AI. Okay. So first of all, we need to understand about the fundamental of digital images if we want to know about computer vision. Let me explain that first. Okay. First of all, image is a matrix of pixels. It's a very basic thing about image. Okay. It's like a arrangement of pixels in rows, various rows. Okay. And each pixel will be having RGB values. That is primary colors, right? Red, green, blue. Okay. And grayscale is one channel. Okay. So in case of normal image, it will be three channels, right? Red is one channel, green is one channel, blue is one channel, and grayscale is one channel, but the intensity will be varying from 0 to 1. So this one is an example of grayscale image, right? So it is actually image RGB having three channels: red channel, green channel, and blue channel. And each channel can be converted into grayscale, like a single color, but with varying intensity, right? It is grayscale. All these things are recorded as like a prerequisite of doing pre-processing of image is for doing computer vision effectively. Okay. And obviously image dimensions are like height, width, and the number of channels. Okay. And that is about fundamental of digital image. Next, now we are going to see about basic image processing. Normally the basic image processing, it's like resizing the image, like reducing the dimensions, right, width and height, and cropping, like cutting particular portion of the image, and rotating and flipping, color conversions. Okay. And other things like drawing lines and circles or adding text. Okay. All these things we need to do as a part of image processing. Okay. These things are recorded when we create data sets for training a computer vision model. Okay, let us discuss those things in later stage. As of now, we need to understand like the basics of digital image and some fundamental about the image processing, right? And one more thing related to computer vision, important thing is CNN, convolutional neural networks. Okay, it's a kind of neural network, deep learning, and it is especially useful for computer vision. In case of NLP, RNN, recurrent neural network, is more relevant. But in case of this computer vision kind of projects, we have to deal with the CNN, convolutional neural networks. It is special type of neural network for images. Okay, the key advantage of CNN is it automatically learns features like edges, textures. Okay, like if you have gone through my previous videos about difference between machine learning and deep learning, you should be aware of the advantage of deep learning over the machine learning, right? It is about automatic learning of features like finding edges and the textures. That and all will save a lot of human efforts and time, right? That is the one major reason these days we are seeing a lot of computer vision related things. Okay, and we need to understand about pre-trained models. Okay, similarly in case of NLP, natural language processing, we have a lot of pre-trained models, right? Apart from like small models, we have even like LLMs, large language models like GPT-4, Gemini, that kind of models are there, right? They are trained with a lot of text, right? Similarly, in case of computer vision, we have a lot of pre-trained image models, and they are trained with large image data set like ImageNet. ImageNet is having a lot of images, sample images, and these pre-trained models like MobileNet, ResNet, VGG, they are trained with ImageNet, like that kind of large image data sets. Okay, because of these pre-trained models, we can save a lot of training time because they are already trained, right? Okay, in case of computer vision, we should know about some Python libraries. One is very common one is OpenCV. It is like it is mostly used for like doing handling images and doing image processing. Like we already gone through that details, right? Like converting the image colors and cropping, like flipping, rotating, that kind of pre-processing. Okay, and converting like multi-channel image into grayscale image, that kind of stuff. Okay, that can be done with this library. It's an open source library. Okay, OpenCV. It is called as OpenCV. We can install it using pip install OpenCV -Python, and we can use it in our Python code by using import CV2. Okay, I will show one sample code using this. And another important library is YOLO. YOLO stands for You Only Look Once. It is powered by Ultralytics. We can install it using pip install Ultralytics. Okay, it's like important library. Okay, it is the actual library for training the image model and using the model for doing object detection, segmentation, any kind of task. Okay, so we can say that that CV2 and YOLO can be used together. It's their complementary libraries. Okay, that initial part of any kind of image projects can be done with CV2, and actual training and a prediction can be done with YOLO. And another important library is OCR for text recognition. It's reading text from image. Okay, that can be done using TestTract. The Python library is PyTestTract. Okay, we can use that. Okay, now let us see some samples. Okay, I already installed, pip installed the record libraries like CV2 and Ultralytics YOLO, right? Suppose if you are doing it first time, just make sure that you are installing it. Okay, I already shown that in the slides. Just you can follow that command. Okay, and let me first show the sample code. Okay, Here I keep it in a symbol.py, just importing CV2. Okay, and then I am reading sample image, this sample image sample.jpg, and just printing image.shape of the image. Okay, that's it. All the other things I as of now I commented out. Okay, let us check that. Okay, file name symbol.py, right? So it is showing the shape, right? Image width, height, and the channel. Actually the sample image is like this one. It is the sample.jpg. Okay, so it's showing height, width, and channel. Okay, here I am uncommenting this one. I am show. It is just for showing the image. Okay, and here using resize. It is for resizing the image, reducing the width and height size. Okay, and again showing the resized image. Okay, let us run this, and whenever we are showing that image, for closing that, maybe we can do this. Okay, so on clicking that it will close, otherwise it will be just showing. Okay, so now we are reading the sample image and resizing it, and then showing the resized image and waiting for key press, and then closing all the windows once we press the key. Okay, let us run it. First it's printing shape, it is showing the actual image, it is resizing, then resizing the image, right? So for doing all these things, we are using this CV2, that library, right? Next we are doing color conversion, right? Using this CVT color, and this parameter color BGR to gray, we can convert the color image into gray image, right? It converted that image into grayscale, right? This actual image, it is grayscale image. This example is for just for knowing about how to use CV2. As I said, it is used for various purposes, especially pre-processing of images. Okay, and it will be useful in doing dataset creation as well as the training process. We can do image pre-processing with the help of CV2. Okay. Next, let us see some YOLO sample. Okay, so as I said, YOLO is provided by Ultralytics. I already installed Ultralytics, that package. So from Ultralytics we can import YOLO, and for additional things we can use CV2. Okay, for handling images and models. Okay, so YOLO, I'm going to use version 8 model and nano flavor, right? It is very lightweight flavor. Okay, so that we can quickly see the result, but the accuracy may not be good. For that we have to use better version. Okay, this is PT, that models PyTorch, that format it will be stored. The weights will be stored in this way. Okay, okay, if you are using first time, it will be downloading this model. Okay, we can use it just for testing one simple image like bus.jpg. This image. Okay, we are going to use this image. Okay, let us see how it's doing. So we used this YOLO V8 that model, right? With that model, actually it is having like a pre-trained data for the labels, like standard labels like bus, truck, person, bicycle. It's able to identify those things, and it marked those things, right? Here it's able to identify the bus. This is confidence score, right? So it is 91% sure that it is bus. Okay, and bicycle, car, truck, it's able to identify those things, and it is able to draw a bounding box around that object, and showing label with confidence score. Okay, suppose if you want to make it identify other objects like this building or this tree, we need to train them. Okay, I will explain about how to train a model. Okay, it's like a training model is it requires like a proper planning and like a set of processes we have to follow. I will explain them. And if you want to use the pre-trained model, we can easily use it. Okay, here we just use this pre-trained model YOLO VHN.pt, this model. We just loaded that model and we just provided this image. Okay, that's it. We got the results. Okay, and we are displaying that results. Okay, so it is a very simple thing, but if we want to make it work for our own requirements, then we have to do the training. So it involves data set preparation, a lot of things. I will explain one by one. Okay, now let me explain about training YOLO model. Okay, here it involves, as I said, it involves a lot of steps. Okay, first we have to install that YOLO model, right? So that we can do it with the pip install analytics. Okay, and we have to then prepare data set. It's very important thing. We need to prepare the data set in a proper way. It should be in YOLO format like this. Okay, it should be like data sets, within that images and labels, and the images folder should contain training and validation, that images, and the labels also should contain the same kinds of folders. And each image should have equivalent or like a counterpart of a text file with the annotations in this specific format: class ID, then x-axis x-sender, y-sender, and width and height. Okay, and all the values should be normalized between 0 and 1. Okay, like it should be like class ID can be 0, 1, 2, 3, like that. X-sender should be, as I said, it should be normalized. Okay, say for example, if it is like 500 by 500 image, and if you want to specify 250 250, I mean x sender 250, y sender 250, like that, it should be like 0.25, like it should be normalized. Okay, it is 500 means 250 should be divided by 500. Okay, 0.5 in that case. Okay, once after preparing the data, I will show that time we can easily understand this. But what I'm currently trying to say is it should follow this specific format. Okay, the data set preparation should be proper. And as part of data set preparation, we need to create this data.yaml file, configuration file, and this one also should be defined in a standard way like this. Okay, say for example, you should have the details about path to the data set, and training image path, and that validation image path, and the number of classes and the name of that classes. Okay, classes is that name of the label. Okay, and then we have to start doing the training. Okay, for doing training, we can use this command YOLO. There we have to specify the task. Like a task is, suppose if you are going to use it for detection, we have to give detect. Otherwise, for any other things like classification, segmentation, we can use it like this. Pose means pose. But no common task is detect. Okay, and we have to specify mode as train, and we have to specify the base model. Okay, and that YAML file name, and the number of epochs, number of iterations, how many times it should be doing the training, and image size. Okay, so we have to run it from terminal like this, or like in the code itself we can run like this, like model train. We can provide the data and the number of epoch, image size, like this also we can use. Okay, but the simple way is we can do the training from the terminal itself using that specified command. Okay, once after completing the training, we can take this best.pt. Okay, it's a best model. Each iteration it will be creating a model, and based on the validation or evaluation, it will be choosing the best model, and we have to use that best model for our actual usage. Okay, we have to use that best model, and we can use the mode as predict, and we can provide our input image. It will be identifying that trained labels, and it will be marking the label. Okay, It's that much simple. Okay, but we have to follow the steps properly. We have to prepare the data set in this specific format, and it should be like the name, like say for example image training. In the train folder, if you are having 1.jpg, then you should have 1.txt in the train folder of labels folder with that name. Okay, that name should be matching. Okay, there shouldn't be any ambiguity or any kind of confusion. Okay, it should be clearly prepared, then only it can understand. Okay, but we should be having one question, like here we have to prepare the label in this specific format. So for that we have to measure the say x center, y center, width, height. It is some kind of like a tedious process, right? Time taking thing, right? But you understand the thing, right? Here using x center, y center, width and height, with that data you should be able to draw the bounding box around that particular object. Okay, that is the thing. Okay, so that thing we can do, like if we have some visually like if you are able to do it visually, then it will be easy, right? We can just mark that area, and if it is able to automatically convert into this specific format, that will be easy, right? So for that there are various tools are there. Okay, cloud-based tools like RoboFlow. Let me show that. Okay, because the RoboFlow will take care of all the things, creating this folder, YAML file, arranging the files in actual format. Everything will be done from there. So better we can use that one. Okay, or we can just have some template kind of stuff like this structure, and we can only for this purpose, because it is time taking thing, right? So for that we can use image label, that kind of local tools that will allow us to mark the record area, and it can automatically create these values. Okay, that is one approach. Or we can do everything in the RoboFlow itself. I will show the RoboFlow example. Okay, the website name is like roboflow.com. Okay, I logged into roboflow.com. Okay, here we can create new project. Here they provided the workflow also, right? Okay, I'm creating new project. Here they provided different project types: object detection, classification, instance segmentation, key point detection, multimodal. I'm choosing this simple one, object detection. Okay, so it is for just like finding the object. So I will give, like, maybe we can use it for like number plate identification. Okay, number plate project. So I added that label as number hyphen plates. Okay, now I will create the project. So as a first step, we need to upload the files, images, right? So first we need to download some files. I will download the files first. Okay, I have downloaded few car images with number plate information. Okay, and now I'm going to upload them here into this roboflow.com. Okay, I have uploaded these images. Okay, and clicking save and continue. Now we uploaded the files, right? The next step is we have to do the annotation, right? Start labeling. Okay, we have to assign that. I will assign to myself. Clicking start annotating. It will be showing images one by one. Okay, it's showing 1 of 6. So we have to first mark that area and choose that label. Okay, now we have completed annotation of all 6 images. Now we are going to add these 6 images into data set. Okay, we are preparing data set. So we need to split that, right? As we discussed previously, it should be having train data, validation data, test data. Okay, we can ask it to split images between train, valid, test. Okay, for training 4 images, validation 1 image, test 1 image. Okay, now we created the data set. Then we can check it in the version. Okay, we can download that data set. Okay, we can choose this YOLO V8 format, downloading zip file to the computer. Okay, I downloaded that. Okay, the downloaded image is this one. I am extracting here. See here, it created that format, right? Test, train, valid, and data YAML. Okay, so test here, within the test, images and labels. Images, test one image, right? So it's showing that one image, and that text file in the labels. Okay, here this X center, Y center, width and height, that information. Okay, and in case of training, you should be having 4 images, right? 4 images, and in the labels, that 4 text files, that name should be matching with that image name. Okay, so all will be taken care by that RoboFlow. In case if you do it manually, we have to follow those things properly, and we need to like create this data.yaml file also. I mean, the RoboFlow will be creating that. If we do it manually, we have to do that. So here, train, validation, test things, and the number of classes and the class names. So now we created the data set and put it in our local. Maybe we can rename it as data set. Okay, so the next step is we have to train the model, right? The model is this one, YOLO v8n.pt. It is here. Our data set is here. Okay, and now we have to train this model using this data set. Here, direct mode train model YOLO v81 data set data YAML. Number of epoch 2, because in my local it will take more time, so I just set as 2, but normally it should be like 100, like that. Okay, may say 640. So now we are training the model with our own data set. Okay, I specified number of epochs as 2 only, so it is just for sample. It may not work properly. Okay, I'm just trying to show you the process or workflow of training a model. Okay, now the training process has been completed. Okay, let us see the details. Okay, here it has created this runs folder, right? Direct train, and here it has created this weights folder, and here we can find this model best.pt. we have to use this one. We can copy this and we can put it here. Now actually we started with this YOLO model, and we trained that model using the data set, annotated data set, and at the end of the training process we got this best.pt, which is trained with our own data. Okay, for training our label. Okay, I mean training that model to detect our label, that number plate. Okay, and here we can notice all the other things, right? Here intermediate files, if we go through that, we can see that it created these kinds of images. Okay, for training purpose. Okay, we can see that, right? They created the mirror image, flipping, everything. Okay, we need not create these kinds of training images. It will be automatically done with YOLO. Okay, and apart from that, it has created a lot of informative things like metrics, right? Confusion matrix, that details, like, so we can evaluate the performance of that training process using this F1 curve. Also it's there. Since we are testing training with less amount of data, it's not that much relevant now. Okay, it is just for showing the flow of process of doing the training. Okay, now we have completed that thing, right? We got the output, that best.pt, and I put it here. Now we can use that best.pt for our inference. Okay, now we can use this YOLO.py for doing the inference. Okay, instead of this original YOLO model, we can use this best.pt, that trained model, right? So we are using that one, and then we can test that with this image tester. Okay, and we are doing the inference, right? And showing that annotation, but it's not able to detect, right? No deductions. Okay, because as I said, we just did just two epochs, right? So it's not enough. Okay. I just wanted to show the flow, right? How to do that training, and then how to use that best.pt for our further inference. Okay. Okay. Thanks. Bye.